Harjoitusmielessä.
Niin,
Joo.
kyllä.
No niin.
Tämä on ihan hyvä itse asiassa. Tosi hyvä juttu.
Joo. Kyllä.
Ja sitten se on niinku harjoitus mulle. Ja sitten mahdollisuus niille, jotka niinku haluaa, niin sitten nähdä sitten taas niinku pari tällaista.
Niinpä. Joo, ihan superhyvä.
Tulee niinku ja muuta ja sillain.
Mutta on se silti eri, jos pääsee tällä ihan paikan päälle katsomaan.
Niin.
Joo, kyllä. Vähän kuin olisi Las Vegasissa.
Mitäs otetaanko kysymyksiä?
Mä itse asiassa, olitteko te varannut kysymyksille sen, että pääsi ajatella?
Joo.
Jukki on valmiina tuolla sitten päälle vaan sieltä, niin sitten kun ensimmäinen puhuja lähtee, niin mä sitten pääsen vasta säätämään sitä.
Joo. Hyvä.
Joo.
Niin ilmeisesti vastaus on kyllä.
Joo, okei.
Et joka tapauksessa ennen kuin se ensimmäinen esittelijä menee tuonne, niin kannattaa käydä laittaa se päälle se HDMI, että se saa signaalit, niin mä sekä laitettu noin päälle.
Joo.
Muuten ne sammuu saman tien noin tykit tuolta, että ne on vedetty niin tiukalle sieltä.
Joo.
Ja sen jälkeen se ei ongelma, kun puhujat vaihtuu, niin nehän vaihtaa vaan piuhan paikkaa, niin se signaali pysyy koko ajan käytännössä.
Kyllä, just näin. Yes, kiitos paljon. Hyvä. No niin, nyt se näkyy.
Mä laitoin sen suoraan tuosta. Jos mä menen laittaa tänne.
Joo.
Puhun vaan se introspiikki, mikä oli tarkoitus. Mulla ei kyllä näe mitään tuolta.
Toi Stream Health on. Tässä on se tää.
Jos me toivottavasti tuleeko se nyt 3 kuukautta.
You got everything cooked up?
Ainakaan se ei tuu varmaan nyt tän. Se ei varmaan tuu tän kautta.
Niin se ääni.
Mistä toi on?
Mut onko siellä nyt siellä se... Sähän näit, siellä on se joku audio.
Oh, sorry. Are you giving some introduction? Yeah. I don't think we need anything to have free speakers. Sorry.
Joo.
Miten audio inputti? Internal microphone.
Se on tällainen kommentaari.
Ah.
And it was like 45 minutes. But you know, I'm at home. Mä luulen, että me nyt tehdään vaan siinä, että se audio nyt menee, mutta se ei ole kyllä toi. Jos se vaikka sammutat tänne.
Noniin, pane pyllyyn se nyt ja...
En mä sitä. But
Meinaatko sä,
yeah,
että...
so let's see. I'm interested in seeing like, is it more or less or something?
You can make it.
Yeah, let's see. So
Sure, if you run through an hour, we will throw something else.
yeah, my idea is that I'm gonna I'll go through it and then I'll see, then I'll know like also for next week.
What is your topic?
It's Tuesday.
Eikö se on kuitenkin tää sama purli? Vai vaihdoiko se sitä jotenkin?
Let's go in there.
It happens every time.
Many people are going.
Yeah, it happens. It sneaks up on you.
And then you realize that you have the whole color. I was telling my husband, I think I will meet you for lunch. But I can't commit. Because I have breakfast and I have dinners and every day.
Yeah.
That's live streaming. I think we will send the link on the AWS Twitter. Yeah.
Pikkunen.
So no one came from Supercell.
Yeah, I don't know. I heard a couple of people say that they tried, but it was cool. It was cool.
No way. So we always have less people on the ones that are.
Oh yeah. That's the thing. That's the thing. Like when you have there's always the no-shows.
We try to calculate, like we buy the 130 or something like that, and we are expecting 80. And today, when I went to check, maybe 10 minutes ago, there was 79. So we don't think we are getting a little more, right? But sometimes you organize something and there's like 40 people because the weather sucks or there's something, and then train, whatever, and then
It's cool, like 100 as hobby or to
no,
this.
they are pro AWS.
Okay, so that's
Joo.
That's nice.
Ootas nyt monesti se.
Yo,
But I'm on my maternity.
I just wanted to say,
I'm on my maternity, so I'm work for them. I'm doing a lot of content creation for AWS. A lot of things on serverless.
yeah, that's nice. Because it's good to hear, because sometimes I think oliko se a couple of days? Yeah.
I don't know, like 6 or
All right. Welcome everyone, and let's get this show on the road. So on behalf of the AWS User Group Finland, I would like to welcome you everyone to this meetup, which seems that it has gathered a lot of interest, and a big thank you for everyone for coming over. This time we are a little bit experimenting with live streaming with not so great results for now, but I'm glad that you are here, so you get to enjoy all the great performances tonight. But if you go to the User Group Finland Slack channel in the AWS Nordics Slack, you can find the stream link there, which you can like post to your social feeds. We are not actually 100% sure if the stream is up and running right at this time, but if anyone knows, let us know. At least we're trying. But without further ado, I'm not going to keep my traditional new and noteworthy session today. I'm hoping that next time after reInvent we will have a lot of new things to share with everyone. But today we have some special programming because the Finnish guys who are presenting their topics at the reInvent conference have promised to come over here and kind of have a soft launch or like trial run of their presentations with us. And the first one is Heikki from Supercell. So let's give a big hand to Heikki.
Thank you.
Tähän niin saadaan jotain ääntä sinne striimiin.
Yeah, hey, good evening
Thanks for joining me in mini Las Vegas, I guess. I didn't know it was so cold. But yeah, so my name is Heikki Verta. I'm here to talk about scaling mobile games and go in a little bit more detail in a while. But first, just to get a feel, how many of you guys are from the gaming industry? Could you raise your hand? And okay, cool. So less than 10. That's nice, because this is actually not that much about the gaming industry. Of course, I'll go to the specifics, but in general, I think it's very much applicable to other industries as well. So I lead the services team at Supercell. Been with the company since 2013. Before that, worked at Unity, or actually at the time it was called Amplifier, now Unity Finland. Before that at FutureMark, and before that at Nokia, as I guess many of us did at the time. I also met some old colleagues tonight as well. So the talk is basically split into 3 parts. First, I'll talk a little bit about Supercell, the team structure and culture. And I know, okay, maybe for this audience, it's not that super relevant, but I'm told by the AWS people that not many people at Las Vegas, at re:Invent, know what Supercell is and what we do and all of that. So I'll talk a little bit about that. And also, so it's because not that many people apparently know, and also because it has implications to how we do things. Then I'll talk about scaling the games and scaling analytics. But first, and again, I left this in because it's a practice run for Las Vegas. I hope you know all this already, but Supercell is a mobile games company. We are founded in 2010 in Helsinki. We have offices here in Helsinki, Shanghai, San Francisco, Tokyo, and Seoul. And game development happens mostly here, but actually we've just started a small team in Shanghai as well. And currently we have 4 games live, Clash of Clans, Clash Royale, Boom Beach, and Heyday. And maybe the image gives it away a little bit. We have a new game coming up, which we've just announced, Brawl Stars, that's been in soft launch and will launch globally soonish. It's a new kind of game for us. It's a 3v3 MOBA, sort of real-time PvP game. So super interesting also from the server side. So to set everything up, I'd like to talk about the challenge, or the big challenge that we're facing, and it's that we have 5 games, or we're gonna have 5 games globally. They're rather big. There's some roughly 200 million MAU, so that's monthly active users across all the games. At peak times, we see something like 4 million concurrent users, and the deployment is fully on AWS. It's rather large. There's some 6,000 EC2 instances, all kinds of instance types. So scaled to the X large capacity, it's something like 20,000 X large instances, but it's 6,000 of all different sizes. Then we run some 200 databases, and that's databases with master and 2 slaves. So it's like 600 machines running the databases in multiple regions. But the company actually is only 250 people, and in a single live game team, there's maybe 20 people. And out of those 20 people, 3 guys are server developers. And for Clash of Clans, for example, that means that those 3 guys manage 100 databases and 2,000 EC2 instances. They maintain all the other infrastructure and develop the game at the same time. So our challenge is how do we operate and develop the games at this scale with such few engineering resources. And and a lot of that comes down to the team structure and culture. And as I said, I'm going to talk about this because it has an influence on what we do. And how we think about it is that everything starts from the team. So the best teams make the best games. These teams are cross-functional, so and vertically aligned. So there's basically, for Clash of Clans team, for example, again, there's the server guys, client developers, QA, artists, game design, data science, everything in the same, all these guys in the same team. So we are organized around the products, not the functions. The culture in a super nutshell is, as I mentioned, all about small teams. That means there's less hierarchy, so less processes, bureaucracy and politics, and more agility and speed. Sort of, it's also more motivating for we feel that it's much more motivating for the developers when you're working, you're having a bigger impact than if you're working in a 400-person team. It's execute their own vision. And everybody, of course, is responsible for making the best decisions for Supercell. So especially the hardest ones, like killing a game. So what we actually do is we try to optimize for speed and passion and less about control. So if I had to put this in one word, I'd say our culture is agile. So agile in the sense of sort of software agile development, but across the whole company, across all the functions. So and this of course has implications for our AWS architecture, and that means that the teams, they own their own AWS accounts. The top level structure also for the AWS accounts is by product or service. Then some of the billing and support and all of that is consolidated, but that's a minor thing. There is no operations team. So the teams practice DevOps. They set up their machines, they maintain them, and all of that. And they are also sort of responsible for the on-call. So all the server developers as a company run their on-call rotation. They can also choose their own stack. So there is no quote-unquote Supercell platform that they have to use. But obviously, there is a tried and true battle-tested platform which sort of has a gravity that the setup for the different games is mostly the same, with some minor differences. And the variation sort of is more on the other functions like machine learning or analytics or support or live ops or anti-fraud. And of course this also means that actually we're not cloud agnostic. So we use AWS managed services to reduce the operations burden because we have so few engineering people. And we feel that if it makes sense, because it's an unknown, whether we don't want to take the cost now of preparing for maybe moving to a different cloud provider, but we feel that okay, if it comes up, we'll cross that bridge when we get to it, because we don't know if it happens. That's sort of the background, and now for the first course. For gaming and how do we feel about gaming and scaling. This is just again a little bit background. This is a super simple picture of our stack, which is actually pretty simple. So it's a traditional client-server architecture. The client runs our own C++ OpenGL engine. It communicates with the server through a binary custom protocol over TCP and UDP. The server is running Java, and we also use Zookeeper to manage the game cluster, but I'll talk more about that in a minute. And the database is just simply MySQL or the Percona flavor of MySQL. for Brawl Stars, which is the new game, we're actually trying a new thing. So Brawl Stars is running on Aurora, so the managed version of MySQL, or the MySQL compatible database that AWS provides. The other ones are just Percona MySQL on EC2, so we've set up the machines, installed everything and all of that, so it's not in a managed setup. Then also some data is stored on DynamoDB, but that's mostly sort of, that's the replays and stuff like that, so not the core data. And how do we, that's again background, and then for scaling, how I see it is that it's actually, it's pretty simple. It's about scaling out instead of up. So not bigger, like this, like you just bigger and bigger machines, but more and more machines. So, and I actually feel that the technology that you use and the algorithms you choose also matter, but much less. So when fundamentally, when it comes to scaling, if you can scale out, that's the key part. But so, okay, that's great, but how do we do it? And it's basically, it's again two things. It's the microservice architecture that we have for the games. That's for the business logic layer, and then sharding the database layer. And I'll talk about both of these things in a bit more detail. So with regards to the microservice architecture, the game is split into logical services. And these services run on different instances. So it's sort of a traditional microservice architecture in that sense, but what I'd like to call it is sort of like microservice light, because it's actually the game is a single artifact. The different services are not running different languages developed by different teams or something like that. There's a single source repository, one language which is Java, one team that's doing it. So it's sort of like a microservice light architecture. And what that enables us to do is to scale out. So the different individual services can be scaled individually. If we need more proxies, if we need more battle containers, we can scale those out without affecting the rest of the cluster. But of course, there is a fair amount of coordination that's needed, and that's sort of the gaming industry specific thing, that in a traditional web application, the load is mostly reads. A little bit, so less writes, more reads. In gaming, there's actually a lot of writes. When you play, you're chasing the state of your game constantly, and that means there's a lot of caching happening on the server. So in all of these microservices, the state is being created, and that means that you can't just take away and replace services. You need to do a little bit of orchestration, and that's where Zookeeper comes in. So Zookeeper is used to it's an open source server for coordinating distributed applications, and it's used to assign roles to the existing instances. So you're a proxy, you're a home container, you're a battle container. And it's also used to orchestrate this sort of graceful shutdown and boot up. So for example, for a battle container, you'd say like, okay, stop accepting new battles, wait for the existing battles to end, then you can die away. But there's another aspect to that. There's also the sort of EC2 aspect. So Zookeeper is used to assign the roles, but then the actual EC2 instances are handled by autoscaling. So there's sort of a two-dimensional grid there. On the left, the autoscaling groups are, the instances are grouped by security group and instance type into autoscaling groups, and that is used to actually provision new servers or remove them from rotation. And then once those servers boot up, they register with Zookeeper and get a role as a sort of first as a hot spare, sort of just waiting, trying to get a role. Like, is there a role for me? Is there a role for me? And once a role becomes available, they'll boot into that mode. So, for example, what happens when a load increases? We first the blue, or actually it's a greenish line, indicates the load on the cluster. This is from a test environment, but anyway. And so when the load increases, Zookeeper is notified that, oh, actually now instead of 5 battle containers, I need 7. And Zookeeper uses the auto-scaling group to boot up a couple of more servers. And once those servers become available, it increases the count on the battle container role from, let's say, 5 to 7. And then these new machines take the load, take those roles. And when the load goes down, Zookeeper again orchestrates the shutdown and then instructs the auto-scaling group to scale down. With regards to the database layer, as I mentioned, it's so that's about the game cluster. So we use auto-scaling and Zookeeper to manage that. With regards to the database, how we looked at scaling is by sharding, and sometimes in the gaming industry, sharding means that, oh, there's a server for, or there's a universe of the game for Chinese players and a universe of the game for European players. But so for us, that's not what I mean. For us, a shard is a sort of a instance of a database which has an identical schema to the other shards, but contains different data. So basically, the accounts of the players are split within the storage. And once when the load increases or the shards become full, we start adding new ones. And this is a manual process. So we look at the load, like, oh, actually, so we need a couple of more, and those are provisioned manually and added to the clusters. And how we balance load between these shards is then by assigning weights to the new accounts being created, as there's constantly people start the game, they play, and then they churn. So there's a constant flow of new accounts coming in. So when a new shard comes online, we start assigning, we take a little bit of weight away from the other shards and start assigning new, give more weight to the new shard and fill it up like that. But of course, this is actually, this is a totally sort of technical thing. The user doesn't know about it. So the shards don't affect gameplay. For failure recovery in the game cluster, we auto-scaling and Zookeeper give us a lot of automation, but actually here on the database side, we don't really have an automated system. So a MySQL masternode failure still breaks the game for that shard, and that means the accounts, the clans, the clan wars, everything that's stored on that server breaks. And we have to handle this manually. But with Brawl Stars, as I mentioned, we started using Amazon Aurora, and we during the soft launch period we've had a couple of incidents where the node has failed, but the failover kicks in pretty quickly. So that's been a win so far. Fingers crossed for us. So that's the sort of missing piece of our existing automation, the database failures. And that's basically the story with regards to games. And next up, it's analytics. And again, I'll set it up a little bit and talk about the sort of how we think about analytics. And actually, so what we believe that analytics can't make a hit game, but it can improve it. So I'd say that we're a data-informed culture, not data-driven. I think at one point that it was sort of maybe emphasized a little bit too much that, oh, we'll just make tweak the color of the Google logo a little bit, and then the data tells us which is best, and that sort of drives the product. We don't think about it that way. The product is the games are driven by the expertise of the designers and the team, and then we use data to sort of validate validate the learnings basically. And of course, also we have full transparency when it comes to data inside the company, so everybody can see any piece of data that they want, and we don't have like as I mentioned, we don't really have these centralized teams. So the data scientists also they sit with the game team. There's no centralized data science team. In rough aggregates, we receive or collect some 5 terabytes of data per day. Inside there is something like 15 billion atomic rows or events. And in general, our data warehouse contains something like 4 to 5. Actually, maybe this is a little bit old number, so it's probably like 5 petabytes at the moment. And what I mean by atomic rows or events, it's that. It's sort of a simple blob of data about something that happened, a level changed for this account, and that's it. So actually, the events don't contain that much information, not that much context, so they require further processing. And actually, the data volumes used to be a lot higher, almost double, but we've pruned some of the less relevant data and use sampling for some of the really high volume cases. But the same as with the games, I actually don't believe that there's one right answer or architecture or pattern for analytics. So it depends on your scale and your needs, and what I'd like to tell you is sort of our analytics story, what we've done and how we've gotten there. And as you can, it sort of starts from 2012, just to make it a little bit shorter, and ends up where we are today. And in the beginning, this is sort of where we started. Before this is like our first data warehouse or analytics pipeline or something like that. And before this, we just queried the game databases. That was our analytics. Like how many new users? We just go to the game database and make a query. But of course, that's not very scalable. All the games are different, and there used to be there was already at that time you didn't have just one game database. There were actually multiple shards. So there was maybe 50 shards at the time in Clash of Clans. So that's also not very convenient. So what we did is basically just make a simple install ClickView, ingest the data directly from the game databases into ClickView, and then do some ETL there. And that's great. It's super simple, but it has some drawbacks. For example, for ClickView, for example, is a Windows-based software, so that's not very super. It's not super cloud native. It's also like today, considering today's standards, the UI, the user experience is pretty poor. Also, it's super slow. So we get data in once a day, and of course, also it would be only what is the state of the database at that moment. So we wouldn't have any intermediate results. And of course, also the data was locked inside ClickView. It has its own data format and own lab. So it's not SQL. It's sort of like a flavor of that, which you use to operate the data. So it's not the optimal solution. And the games, of course, also were growing. So we realized that, okay, yeah, maybe this is not the optimal solution. We need a better one. And we started with looking at the data pipeline. So about how can we improve the extraction of data from the games. And the first thing we did was like, okay, we only have the game database state. It's slow. So let's start sending events from the clients. Like whenever something happens, we'll send an event. We use HTTP. We collect those, store them somewhere. Boom, there's your data. It took, and this again, quite simple. The scale was pretty large. It was something like 10 terabytes a day, 60 billion events. So it took a little bit of engineering, but of course the processing is really simple. You just receive it. You receive the data, you do a little bit of processing, you store it away. But it still took a little bit of engineering effort to get the receiving and processing to scale, but not rocket science. We were able to do it, and it worked pretty well. But the major challenge with this solution was that it suffered from poor quality of the data. So what was coming in through the clients was sort of mismatch, sometimes broken, sometimes missing something, sometimes duplicating something. And actually what we wanted to do is we wanted to calculate all the KPIs based on this event data. And with the data coming just from the clients, the sort of accuracy just wasn't there. And our sort of goal was to achieve the 1 promille accuracy, and with this we couldn't do it. So what we ended up doing was adding another event stream or another event pipeline, and this time coming from the server. So we thought, okay, we can't trust the clients, but we can trust the servers. So let's do that. So here it's very similar, except for that we were afraid that the scale was on the game servers was the load was pretty huge at the time, still is, and we were sort of scared a little bit, like, oh, we don't wanna mess anything up. We don't wanna make it as light as possible for the game servers. So we actually ended up with UDP for the protocol. And when you're inside the Amazon data, inside a single region, the sending and the receiving part, it actually works pretty well, and we've definitely hit our target with this. So we sort of solved the quality problem with the server side sending of the events. And this, as I mentioned, this approach is pretty simple. You get a lot of more details than just the database, but it still suffers from a couple of sort of downsides. So you don't have, again, you receive the data in real time, but then there's processing and batching up of the data right into S3. So you're not seeing you don't have real-time access to the data. You have maybe 30 minutes delay. And of course also the data, when you receive it and you're processing it, it lives somewhere. And if there's a failure, there's a risk of losing that data. And again, we wanted to calculate the KPIs from that data, so we don't want to lose 30 minutes of data. And of course also the data ends up in S3, in files in S3, and that's the only way to consume the data. So what we did is we actually we wanted to add a real-time component there, a streaming component, and we went with Kinesis. We added Kinesis as sort of a middleware to the picture. And this was late 2013, just when Kinesis was launching, but we felt good about it, and actually it has delivered super well. So it's been really stable since the beginning. And actually the reason why we chose again Kinesis over Kafka, for example, is the lack of, or the managed nature of that service. So with Kinesis we get sort of 80% what we want, and we don't have to do ops at all. So you click, I create a stream, I want this much shards. Again, they talk about shards also, but they mean a different thing. And that's it, you don't need to do anything. So for that, it was great for us. And also what we did, we sort of split it in two. We still receive the events as we did before, but without that much processing, we put them into Kinesis. And then from Kinesis, we read it out and write it to S3. And in this, we also changed the packaging a little bit. So instead of gzip, we started using LZO. So quite similar than before, but with Kinesis in the middle. But the key thing that this setup enabled us to do is to get real-time access to the data. So it actually unlocked a lot of new use cases. Nowadays we update a bunch of search indexes based on that data. We do real-time analytics. We do real-time data integration, so we pass along the data in real time to our partners. And there's a bunch of support use cases as well. And this is something that we don't really have a name for it, but I call it the streaming pipeline. The first one was the event pipeline, this iteration, the streaming pipeline. And the benefits were quite nice. So the data, now it was safe from local failures. We trust AWS, it's safe there. We have real-time access to the data, and there's multiple ways of consuming the data. So not just reading files from S3, but also streaming it in. A little bit about the details. We basically have two main streams with regards to Kinesis, one for client events, another one for server events. And Kinesis, same as with Kafka and these streaming solutions, they give you the option or they guarantee you at least one semantics and strict ordering if you use a specified partitioning schema. So if you partition the data in a static way, you can be sure that you receive the data in the correct order as well. But what that means is you might end up, if your partition key is, for example, the account ID of the player, then it means that you might get like uneven load between the Kinesis shards. So what we actually do is we partition randomly. We just assign a random partition key to all the Kinesis records, as they are called. And what it means is that we actually lose the ordering. But what we gain is the uniform load between the shards. So again, that's one thing less to manage. You can split those shards in Kinesis, so sort of you can manage that. If there's too much, on this shard there's too much traffic, and this shard there's too little, you can split or merge the shards. But again, it's sort of extra work you have to do. And also, we use the Kinesis client library to consume the streams, and I think that's been a big help. It's actually producing, like putting in data, that's not difficult, but consuming, it's actually non-trivial, and KCL makes it a lot easier. And as I mentioned, this is sort of the 20% that we're missing from Kinesis, and the challenge here is that our main streams, they are quite large, so there's some hundreds of shards. Again, it's a Kinesis shard, so it's a unit of scaling in Kinesis. In those streams, and something like 100 megabytes of data per second, and they contain multiple event types. So all the different types go into the same stream, but not all the clients that are reading that stream are interested in all the events. So our solution for this is that, and we don't want we don't want to make all the clients have to read like all the fire hose of data. So what we've added in between is sort of this dispatcher application that reads in the big streams and has a bunch of configuration that then splits, like, okay, for this application it needs these 5 events, and puts them in a new stream. For this application it needs these events and puts them in that stream. And so with this we're sort of, this is something that we've been asking AWS for a while. And so if you see them and you have the same problem, put the tick box there that please make something like this in a managed way. And that's sort of the top part, the analytics pipeline part. And then let's take a look at the data warehousing side. So as you mentioned, we started with ClickView, didn't really meet our expectations. So our next iteration was this. So we were, okay, ClickView, that's not working for us, but we like the simplicity. So let's just replace ClickView with a columnar database, and we chose Vertica. At the time, this was some time ago, so 2013. So at the time, Vertica there wasn't that many options. Nowadays, there's wide variety of sort of columnar or distributed database that you can choose from. But Vertica was used quite a lot in the gaming industry, and we got good references, and we chose that. So the story begins sort of where the pipeline part ends. So from Amazon S3. So from S3 we use Azkaban, and Azkaban is sort of one of these workflow managers like Airflow or something like that, but created by LinkedIn. So Azkaban sort of coordinates that flow, loads the data in, or manages the process of loading the data in from S3 to Vertica, and then we do a lot of SQL-based ETL inside Vertica. So we aggregate the data, we process it further inside Vertica, and then everybody just queried Vertica with SQL. And this is, it's again quite simple. There's a single source of truth inside Vertica. It's easy to query. And this approach actually worked. Worked pretty well in the sort of terabyte to tens of billions of rows of data. But there are some challenges that we ran into, and the first one is the spiky load. So you have to, for this approach, you have to provision your database resources based on the peak load, and it's going to run hot during the ETL. So when you're running your ETL, the cluster is running hot, it's difficult to run your queries at the same time. And then when you're not doing ETL, it's idling. And you have this huge cluster, and you're getting a couple of queries every now and then. Also, Vertica is not really a cloud native. It's coming from a legacy world of data centers. So it takes a bit of effort to scale it. And again, we don't have a big team to run it. So that's a problem for us. And also the sort of the storage and the compute. So the query engine and the storage engine are tied together inside there. And of course, also for large data sets, even a columnar database cluster has its limits. So we were hitting these limits and struggling a little bit, and we started thinking like, okay, so what would be the next step? What are the things that we want to improve? And what our goal was sort of to try to limit the amount of data we put into Vertica. Separate compute, sort of the query engine from the storage engine, separate ETL processing from the querying for the sort of standard the dashboard querying or the data science querying, but maintain the single source of truth and utilize the flexibility of the cloud to optimize resource usage. And our plan, what sort of came out of that, was a plan to, instead of use Vertica, shift and use S3 as the single source of truth. Store everything in S3 in Parquet and use Amazon EMR for ETL instead of Vertica. And once that is done, only load the results into Vertica. So the aggregated accounts and KPIs and stuff like that. And this is sort of what it looked like. So again, it starts from Azkaban controlling the process, but this time the heavy lifting is done in PySpark and Spark SQL on EMR. The data is written, read from and written out to S3 with the final format as Parquet, and S3 remains the single source of truth. It also contains all the data, so all the raw atomic level data, and then the aggregates, and then the KPIs. Then, once that processing is done, only the aggregates and KPIs are loaded into Vertica for easy access. And the atomic data, the 5 terabytes, 15 billion rows a day of atomic data only lives in S3. And during the ETL process, we utilized the Amazon Glue data catalog to populate in the schema or the new partitions that keep coming in. So then we can integrate that data with Amazon, with Athena and EMR. And then the querying happens through all of these 3 sources. So Vertica for the KPIs and aggregates, Athena for the sort of ad hoc querying. So actually, all data is visible there, but it's not. I'd say Athena is not a replacement for a sort of SQL-like database. It has some limitations with regards to concurrency, for example, and also it has some, because it's based on Presto, and Presto has a sort of limitation with regards to schema evolution with complex data types. So and our data has a bunch of that, It's sort of, I wouldn't use, my tip maybe here is that Athena is great, it gives you SQL access to all your data, but it's not really yet useful for your generic, your only source of querying the data. So it's more useful for ad hoc queries, not your everyday dashboarding needs. And the benefits of this approach is that we get the separation of compute and storage. So the S3 scales super well for storage and EMR for compute. EMR also scales for very large data sets. We run in our daily ETL, we run maybe we spawn 9 clusters, some hundreds of machines, and it's been scaling super well. Also, we can use dedicated clusters. So there's a cluster doing the ETL for each of the games, for example, and then they do the ETL, they run hot during that, and then when the ETL is done, we just disregard, we shut down that cluster, and that's it. We only pay for that time that we use. It's not running there all the time. And also, it's for EMR. That's for us. It's a familiar environment. So our data scientists are familiar with the Hadoop ecosystem. So EMR works well for them. There's a couple of tips, sort of like, because instead of, if you're using EMR, not use EMS as so this system or with consistency. And also that's actually sort of a workaround. It's called this consistent view feature in EMR that's designed to get the individual consistency. You have a process then you move on, you have another step that wants to read that data, but actually maybe because of the eventual consistency, maybe this new step doesn't see the data. It's there, but it doesn't see it yet. So this sort of consistent view feature helps with that a lot. Also, you might consider, if you're considering this approach, to use a custom AMI for the clusters. That makes the startup much quicker, because there's a bunch. EMR does a bunch of installing things when it boots up, so it can take up to 15 minutes, even more, to boot up the cluster. So you might wanna optimize that a little bit. And also, of course, it's if you are not running dedicated clusters, you're running transient clusters. What you can do is use the spot instances or the fleet feature to reduce your cost. And so after all of that, it gets us sort of today into 2018. That's the setup that we are running actually right now, and we're pretty happy. Of course, there's some lessons learned during the trip, and something that things that still remain to be solved. With regards to scaling, I think our learning is that the scaling at its core is determined by your architecture. So the algorithms you use and the technology you use, they matter, but mostly it's about what is your architecture. And also, you don't need a super fancy tech stack to scale. Our stack is actually super simple. It's just MySQL, Java, and Zookeeper on EC2. And we run clusters of thousands of machines with that stack. So the microservice architecture and database sharding gets you far, and the same goes for both games and analytics. But microservices do add complexity. You have to think about how to route your messages inside the cluster. What if the sending fails? You have to do retries. The logging becomes more difficult because everything's spread out. The state is spread out in the cluster, so it's not a silver bullet. So it's not that, oh, do it for everything. No. Keep it simple if you can. Then, if you need it, do it. And also, what we've learned that, and as I think you guys know as well, that in the cloud things fail, and just assume it. You can't avoid it, but sort of work around it and do some automation to detect and recover from that. And it's not actually that it's not again super difficult, and you'll make updating your infrastructure a lot easier. For analytics, I think the key points is please try to separate your compute and storage. It makes scaling a lot easier. Also, if you have access to the data in real time, it unlocks a lot of new use cases. And also, I do believe that you should focus on the fundamentals. So that means make sure you have reliable and scalable data first, then think about the higher level use cases like machine learning or BI or what kind of dashboards you want to do, because all of that relies on you having good data. So start with the fundamentals, and also think about how do you define your schema, and that's actually something that we don't really have a good solution in place at the moment, and we've shied away from doing sort of automatic schema discovery because of the complications that sort of entails. But you still need the schema in a lot of places. So thinking about when you're thinking about your data warehouse analytics pipeline, like think about how to handle and share the schema and the evolution of that schema in your architecture. And finally, no, don't try to stay away from the data police. So it's easy to think like, oh, and we actually started out this way. Like we had a set of supported events, and you'd have to ask someone to, oh, I want to send this event. You need to ask someone to add it, and all of that. But that gets in the way. It doesn't scale. The way to get the most out of your data is to make it available to the entire organization, both to produce and consume. So try to stay away from the data police. With regards to the culture, I think it's fair to say that I believe that the best thing about Supercell are the independent teams. We get a lot done with small and independent teams, and we don't need we don't need a large centralized engineering team to run global games. But actually also the sort of most challenging, in my opinion, the most challenging part of Supercell are the independent teams. So with that agility and independence, it creates a degree of chaos, and it's a particular challenge for things that sort of fall between the teams, and for example GDPR or something like that you need to solve across the organization, but it's not no single team owns that. But in the end, I do believe that the benefits of speed and the impact you can have and the empowerment you feel as a developer far outweigh the cost. And with that, I'd like to say thank you. You've been an awesome practice audience. And if you have any feedback, I'll be around. I was told that we can have questions. Are we still on time to do that? If you have any, or if not, you can find me at the bar, I guess. Thank you. Oh.
How long have you been in the cloud?
Sorry?
How long have you been in the cloud?
Yeah, I guess the jargon goes, we're cloud native. So we've started with AWS in the beginning, since the founding of the company. Yeah.
How are you scaling the Kinesis stream?
Yeah, so the question was how are we scaling the Kinesis streams, and that's actually super simple. It used to be a little bit more difficult. You used to have to
manually go in and split there was a bit of math with huge big numbers that you had to do to split the streams, but nowadays actually AWS provides some tooling for that to either split or merge the shards. But in like super high level and it's actually very simple. You just go to the console and click I want more shards. With the caveat that you should, if you're using KCL, the Kinesis client library, that sort of works it out for you. So when you scale the stream, new shards are created, old ones are, I don't know what, closed, I think is the term, and the reader has to deal with that. So if you're reading the stream yourself, there's a bunch of things you need to do, but if you're using the KCL, it does a lot of that stuff for you. So it's actually super easy to scale those streams, but we don't, for those we don't do any sort of auto scaling. So because it's something that you can do every now and then, but because of how the system is architected, I don't think AWS sort of wants you to, like, on a daily basis go up and down with regards to the shards. Yeah, so the question was, do we use the Kinesis data analytics feature, and we don't. We've tried it. It comes with a bunch of little bit of limitations. One is that you have to, it relies on a strict schema and our streams are sort of, there's multiple types of events, so there isn't really a great fit there. But we do use the sort of the fire hosing features for some use cases, sort of to stream data into Redshift. So some not the core analytics pipeline, but some other parts we do use Firehose to stream data into S3 or Redshift or something like that. But the analytics not that much.
How do you test your data pipeline? We have several services that
Yeah, so the question was, how do we test the data pipeline, and that's a good one. We struggle with that. To be honest, we tested a little bit, but because we haven't figured out a good way to do it. Same for and for the logic, it's not that difficult to test. For the logic, it's not that difficult, but to test. But the data is the problem. Having good sets of test data that keeping, like because the schema keeps, because we don't have that data police that's looking at the schema keeps evolving, and that's usually what breaks, what causes the failure. It's not that something happened in the logic, but that something happened with the inputs that we didn't expect. And so actually this is maybe not a satisfying answer, but we actually don't have a good solution for that. So if you, I'm happy to hear if anybody has a good solution for that.
Any challenge with AWS Aurora?
Challenges with AWS Aurora.
Looks is they say 5x fast and the 10x cheaper. So how you are?
Yeah, with regards to the scale or the performance, we've started using Aurora with our new game. The scale there is not that large at the moment because it's still in soft launch, so it's been working out well. We did actually have problems with our load, so we started testing with our load testing environment, Aurora, and we did actually have some problems there. We were sort of crashing actually the database, but we did that's it. Yeah, it sounds not so great, but we did work with the AWS with the Aurora team to get that fixed, and they were able to find the issues, and now the product is better, I guess, for everybody. so it looks like the performance is good. We've been using it only in soft launch, so I guess time will tell. But so far so good. Another little challenge that we've had is that we've tried to, because we're using pair column MySQL, we've tried to, with regards to the other games, like if if we would migrate an existing game over from Percona equal to Aurora, we'd like to have a sort of way back, and that means being able to replicate both ways. And we've struggled a little bit with that, but I do believe that those issues have also been resolved at the moment. So that's something that we're looking into because we don't want to like take the jump and then the door closes behind us, and if something goes wrong, we'd like to have a way back as well, just as insurance. Yeah.
Okay.
That's it.
Yeah.
Thank you. Yeah. I'll be around, so if you have further questions. Yeah. Thank you.
All right. Big thanks to Heikki. We'll take like 2-minute short break for you to fill up on beers. They are, by the way, they're provided by Cybercom. Big thanks for sponsoring this space and the drinks and everything. So go to the bathroom, fill on the drinks, and 2 minutes, and we will continue with Mika from Rovio.
Varmaan voisi sanoa, kuinka paljon teidän kuukausimaksut on jotain ihan posketonta noilla vuotta.
No on kyllä siis sehän on kyllä niin kuin jonkun verran, että siis sehän on niin kuin Amazonhan se on niin kuin sehän on niin kuin miten se sanotaan premium palvelu, että kyllä se niin kuin siitä joutuu myös maksamaan vähän sen, että
kuukausimaksut.
Joo.
Sulla oli yksi ainakin typo siellä Outweigh, pitää olla yhdessä.
Okei, hei, hyvä. Joo, niin siinä ihan lopussa. Okei, hyvä.
Well, not only.
Well, you have like 15 minutes.
I'll explain.
Joo.
I mean, we can keep it shorter. I'm sure the Finnish audience doesn't just...
But usually they have a lot of questions.
Yeah, that's like 15 minutes. I'll answer everything I can.
Because then there is vessel stuff that might be a problem. There's talks to see a friend as well.
Se on itse asiassa se kans pysyy niinku tulee uusia featureita. Se on hyvä sellainen
We don't have the slides.
Ei saisi olla. Jotain näkyy.
sold it away and then it was bought by AWS many years ago. And then AWS now is another company. I don't remember the name, and then it was bought it. They keep it out of the company for many years, trying to sell it. And now it's sort of back in the but that's old division from old unit. Ah, you are not.
See how it goes.
Good luck. So you are flying to US? Okay.
I've been there twice, but not for a sponsor.
Ah, okay.
Very done. But never really.
Many people watching. You need practice.
Well, the type of presentation I have is not even video, so different thing is breakout sessions. It's a bit special. Doesn't change.
So how is Roger nowadays?
The team has completely changed.
Yeah, some of them I noticed they went into this new hatch. But it's so they have an Android client, but I don't think they have anything on iOS, or do they?
Sometimes meet one.
In which building are they now?
They're old.
All the buildings. Okay, yeah. Okay.
We are now at 7.
Old Microsoft. Do they still have Microsoft?
No, Rovio completely.
The whole building. Yes. Well, it has to be Oh, so half of those times. Okay, that's about But so, are you still making movies? I think the last one was quite huge for you in terms of income.
Yeah. Second is pretty much
Ah, okay, so it's not yet out.
No, it's coming next year.
Ah, okay.
Yeah, let's get the show. Just put this here for the streaming audio. Joo. Mistä menee vaan ääni tuonne striimiin, niin ettei tulee tästä. Joo, toinen asetuksessa.
All right, everyone, let's get the final beers and let's get seated and then we will start. All right, Mika.
Hello everyone, I'm Mika Linanoja from Rovio, senior cloud engineer, so thanks for letting me practice my reInvent session here. First time presenting it outside of our company and in the first place presenting in any such public setting, so please be gentle with me. Yeah, so my session is a bit of a strange child, so it's a chalk talk, which is different from the previous one, so it's a kind of short presentation and then a Q&A. So in some of the Q&A sections, people in the chalk talks do some drawing, but I won't be doing any drawing, so I'm expecting questions. And the title is basically how we use at Rovio CloudFront the AWS CDN for secure API acceleration. I'll get into the naming of the title in a bit. Basically, it's mostly about CloudFront and the edge services. So first, the agenda here. So presentation goes like the intro about me, my company. Well, most probably everyone in Finland knows Rovio. Then kind of what sort of setup we had and have for the infra. And then why go with CloudFront for this use case. Then a kind of description about the solution. Then our challenges and findings, kind of results, some numbers there, and then the Q&A. So the first sections, I had a really kind of hard quota on the amount of slides I can have. So it's like basically like 8 slides, and then I have a lot of extra material in case you ask specific questions. So the presentation bit is around 15 minutes. So my person working around 12 first at Nokia, so here in England, been at Rovio for like 6 years, so it's quite a long time in the gaming industry. My background is in QA, software testing, then eventually like releasing, and then continuous integration and continuous delivery deployment systems, and doing those and working with Linux all my work life kind of then paved way for me to kind of move into cloud engineering. So nowadays my job is to keep the Rovio games services platforms up and running 24/7. So cloud engineering. The company doesn't need much introduction here. Games first entertainment company. So of course you all know Rovio from Angry Birds and all the different mobile games. Founded now 15 years ago. People mostly in Finland, in Sweden, and then some offices in UK, US, and so not fancy slides or animations or any birds flying really here. So just going to talk about technology and the hard code. The presentation slide amount is kind of limiting on the. We have a fully cloud native server infra running on AWS. Sort of microservices architecture, sort of monolithic bit mix and match. So we started the platform already the cloud in mind, so there's no other legacy. And the platform serves all Rovio games basically. It's around 1,000 instances at the moment. It can grow linearly with traffic, so it's like endlessly scalable. We use a single endpoint in our production environment for handling all the REST API traffic, and we use a third-party load balancer and proxy software, so we are not using the AWS load balancing solutions at the moment for this platform. And other than that, we have easy-to-instance running in private subnets for the platform. Then the single endpoint is behind the DNS. We use an external DNS provider, DIN. More on that later, what we do with it. And then basically we had elastic IPs of the proxy and the software running in a round-robin DNS, and with some help monitoring there to handle breakages of the proxies. So this is our setup before we had CloudFront for the APIs. And then about the motivation. So we were thinking that what would happen to our business and our services if somebody were to attack us. Basically, we had no good way to mitigate a DDoS attack, which are quite common these days. Somebody gets pissed off at your game, they find some botnet from somewhere and crash your servers. It's not that hard to find the URLs. Of course, the limitations with this sort of setup is that cannot scale the load balancer itself endlessly. We have a commercial license for the bandwidth. And of course, even though the web scale for the application servers that's scalable, there's always some limitations and manual actions with the databases. So in case if we would have a DDoS attack and huge amounts of traffic suddenly, then we would hit some limits. So in the worst case, we would lose our business as the money comes to a gaming company from in-app purchases and from ads that our service platform handles for the games. And well, I could say that we've been extremely lucky. Nobody has attacked our platform, but now we have protections in place, so don't do it, but it should handle attacks. Yeah, so the solution answer to our questions, AWS Edge services, so not just CloudFront, I think they prefer us to use this moniker with the Edge services in general. We were talking with our cloud solutions architect assigned to our company, and he was suggesting and saying that he has some past experience that why don't you try to use CloudFront for CDN and AWS Shield Advanced for DDoS protection and this web application firewall, or is it access firewall, WAF anyway, to block some traffic. So that was a kind of suggested solution from him. And then well, it sounded like a good idea, so we started with a proof of concept. So we were looking at the possible benefits of this solution, and we came up with a list of four things that would help. And well, primarily was the DDoS protection, so which we sold this idea to the management, got the go-ahead. Then kind of interesting thing, which is sort of more related to the title of the presentation, so acceleration, so reduced latencies across the globe for API usage. And at first we were a bit naive and hopeful that we could get some nice cost savings and utilize caching of the CDN for API, parts of the API traffic, but that's not really true. So it's kind of a full cache off setup, and it has some costs, but more on those later. And of course, important thing is future proofing. So the CloudFront Edge provides HTTP2 and IPv6 support, so mobile phones, games running on them can connect on newer protocols. It's quite nice features, and you just toggle it on and it just works. So here's a picture depicting the setup, more or less, a bit high level. So gamers depicted by the red there, running the game on their phone, they connect to the edge. So we have the CloudFront distribution there, then we have the web access firewall and Shield at the edge, and we have a kind of endpoint URL. Maybe you can read it out or not, but it's not hard to find if you use a proxy with any game, so it's not like it's a big secret. So behind that, in the CloudFront distribution, we have the origin server, which is the actual source of where the APIs reside. So for that, we have another endpoint, which we manage in the DIN. We use a service from them called Traffic Director. Nowadays, you can basically use Route 53 and friends to do the same, but for historical reasons, we have the company DNS at DIN. So you have a kind of origin URL there, and for that we have a DNS round robin. So in the old setup, we just chop off the first box, and that's pretty much that. And behind the origin server, we have the VPC in AWS. So public-facing proxy cluster. The software is Pulse Secure Virtual Traffic Manager if somebody's interested. Of course, you can use ALP, ELP, and NLP from AWS. This is pretty advanced proxy software, commercial. And behind that, we have the application server. So this is the setup on a very high level. And more on the how. So this is what we needed to do. Of course, make a new CloudFront distribution. We knew the tech from before, as we have some static asset use cases, or at that point had some static asset use cases and from history. So we knew how to set it up. So we needed a new DNS entry for the origin server, for the new, and then we needed to find out the optimal settings for the CloudFront distribution when you use API traffic. So instead of the usual CDN use case where you just treat it as a cache and you have all the caching enabled to make the downloads faster all over the world, so we wanted no cache. So I can show it's asking me for kind of neat details setup here. Then in addition to CloudFront, the AWS Shield, the Shield Advanced needs a kind of subscription, so you toggle it on, but always enabled for pretty much all of the public facing AWS services as they use it for their own DDoS mitigation. But for this advanced version, which is a paid service, you need to toggle it on. And then for the CloudFront distribution, you create a web ACL, so access control list, which has rules to filter out any unwanted traffic. If you have secret endpoints or endpoints where you have admin control, you don't want the public at large being able to access them. So you can do IP blocking with the WAF. Previously, without the WAF, we had all the IP blocking and access control on our own proxy cluster. Bit uncertain how it handles with load in production. We want to have a quick way to roll back. So if something unexpected would happen, we had a good way to remove the whole setup and kind of revert back to the old way. And kind of shortly the challenges and findings. So it's not all roses, but it's looking quite good. So we've had the setup in production in front of our platform since February this year, and it's going strong, so for us it works. We kind of had in place no true end-to-end latency and telemetry measurement from the games to our services and back. So we were working under some assumptions and synthetic tests. So if you're considering such a setup, it will help tremendously. If you already have in place a system where you have proper telemetry, like HTTP connection statistics from all your players or application users. We're actually introducing such a system now due to some China use cases, so it will be helpful to fight latency challenges in that country. So if you are considering such a setup, we recommend a gradual rollout. So if you can control your infra in a way that you can do it if you have multiple games, so if you can do it per game or per application or per region, it is less risky. So one big problem we found out in the testing and when going live was that when you introduce another proxy basically in front of a proxy, there can be some unforeseen consequences. So in our case, for some Android use cases, the CloudFront seemed to be closing connections when it received a response from our proxy, and turned out there's a interesting HTTP 100 continue header. I'm not sure if it's a header, it's like a protocol message related bug. So we had to ask for a hotfix from our proxy vendor, and they were interested in our findings and did the fix quite quickly. So the Android for specific use cases could work again. We've been running the hotfixed version of the proxy ever since. Works nicely. So this was the only kind of functional major issue we faced. And with the CDN systems, it's a volume business, so you have to consider the pricing. AWS CloudFront does have request amount-based pricing tier in addition to the volumes, so data transfers. But you can negotiate on those things if your volumes are suitable. But it's good to keep that in mind, that there is a kind of request amount-based pricing tier as well. And with the API traffic, it's lots of requests, small, unlike in the usual CDN use cases where you have big files served. And our kind of final finding is that the latency improvements, so the acceleration of the API at the edge, is helping us. So the improvements are true. I don't know if you can read the shell screenshot, but here's some numbers. So I was running tests in 5 different regions. Basically, it's just EC2 instances created into new regions. So it's a bit synthetic, but it gives the global picture. So I was doing tests with curl, like 50,000 iterations, run about a week from each region, and the findings were mostly green. So the second one is a bit of a misnomer there, because it's basically outgoing traffic from inside the data center at AWS to CloudFront back to the same data center. So it's an invalid case in that sense, as nobody will be probably playing Angry Birds games at the AWS data centers. In all other cases, the latency is reduced significantly. And if you want to know how, you should ask me, because I have further details about it. That's it. I've hit my 15 minutes. I don't know if it was that, but a bit more. So the format of the chalk talk is next up to you. So ask me anything. I'm not a super CloudFront expert, but I have some more technical details to tell you if you're interested. The paying, at least we use that form, and then you can use it into any resource for the same subscription fee across the whole organization. And so you can attach the CLS to CloudFront distribution to Elastic. Even without CloudFront, you could use the DDoS protection if you have IPs. This feature did not exist when I started prototyping with this, so it's a nice new thing. Next one.
Do you have any first-hand experience working with DRT?
No, we have not had any attacks, so I have not had any reason to contact DRT. There is a CloudFormation stack they provide, which you can run, which creates a cross-account role for them. So after that, they have the access to your system, at least the CloudFront distribution. And that's the bit that saves on the latency. So the TLS handshake is pretty heavy operation. And when you have a big part physically of the connection being maintained open, so then the connection establishment from the end users is basically just from their phones through their ISP network to the CDN edge, wherever that may reside, hopefully geographically close to you. And then the connection from there onwards is always kept open, so you have a data pipe there. And with this kind of theory, it seems it's reducing latencies. At first, we were also thinking to actually terminate the TLS at the edge, but the solutions architect said that the internal network is not completely secure, so it's better to run TLS all the way to your own VPC for security reasons. And it's a kind of nice extra thing that we get with this is that you save on memory and CPU as the CloudFront sits in front of you and handles most of the TLS. So if you have a kind of always open transfer pipes connections to your origin server, the origin server does not need any more much resources. We could reduce the instance sizes of our own third-party proxy. So that's the theory. I think it works for us at least. Anything else?
You said about the CloudFront cost. So
yes, so the costs about the CloudFront. So some CDN providers, let's say like Akamai, only has volume-based price tiering. So basically, the more you transfer, the cheaper rates you could get, and they don't have any request-based pricing. But AWS CloudFront has request-based pricing. So if you do quite few requests but huge data payloads, then the price is similar. But if you do API traffic where the payload is few kilobytes and you have millions of those, then the request-based pricing might actually be higher than the volume-based pricing. So you need to talk to your solutions architect to come up with a plan how to overcome this limitation. Anything else? Anyone interested in our volumes? I have a slide about that.
There's one question there.
Yeah, I'm blinded, sorry.
Okay, so how have you deployed the whole thing, and is there any problems with slow updates on the CloudFront service?
Actually, it was sort of a one-off setup, so it's not like we keep changing it. So it was pretty much created manually. We are actually automating it now through Terraform to be able to modify the WAF and the CloudFront distributions, but it's pretty static setup. So I set everything up by hand, pretty much. But that's of course not a modern way, not recommended. Use infrastructure as code. So I can, yeah, I'll show you the slide if I find it. Text is really small on the preview. Okay, so these are the numbers, no big secrets there. So we do about 40 billion API requests each month, which comes to around 50,000 API requests per second. So that's an average. On peak times, it might be double that. The volumes are actually around 120 terabytes a month, so a constant stream of 400 megabits per second. Actually, before taking this into use in production, we did lots of estimates. How much would they be to be able to calculate the costs, of course. And the estimates were higher than the real numbers. For the request per second, it's not that hard to get it. So that 20,000 was just a sleeve number I came up with. The data transfer is actually a bit tricky, as we were not using any of the AWS hosted load balancers, and our third-party load balancer proxy software does not really tell this amount unless you set up some nasty SNMP metric systems, which I can't be bothered with. So my estimate for the data transfers was based on basically looking at the network interface level and the CloudWatch metrics for the instances, and they were quite a bit higher than what actually is the kind of the payload traffic that gets routed. There's communication towards the services inside the VPC private subnet, so those are extra there. For the next time I know how to estimate it better, but as you see there's like a 60, 50, 40% difference easily with the volumes. But if you're using Amazon provided load balancers, it will probably tell you outright. Then it's easier to estimate the costs. But we were kind of in the ballpark, so some thousands there, some thousands here. Yeah. Yeah, that's that. Anything else?
Regarding the web application firewall, what kind of challenges have you had, and do you have a lot of different rules? Or?
I can show you the simple rule config we have. I have a screenshot of that as well. So there's a single web ACL for the CloudFront distribution. Probably you can't make out, but I have a summary slide about these screenshots. And then we actually, well, this is from our development environment, which we call Smoke. It's only 3 rules in the web ACL, so to allow some like known IP ranges to connect. Our dev environment is kind of blocked by default, so you can't go there even if you know the URLs unless you come to our office. So the rules themselves are kind of basically simple and or just IP lists. So allow connections from this bunch of CIDRs, our office subnets and a few subcontractors. Also, some of our services inside the AWS VPC connect through the CloudFront, so that's kind of suboptimal design, but non-performance critical use cases like some admin boxes or some Grafana's or something. So we have allowed in WAF also access from inside our VPC through CloudFront and back to the VPC. Yeah, there's just the IP list. So this kind of summary of the WAF setup we have. So single ACL, web ACL for each environment's CloudFront distribution. And in the dev, we kind of block by default if things don't match the rules. And we have those 3 simple rules to allow in known IPs, our office, AWS basically. And in the staging and production, which are more open, we allow all requests through the CloudFront by default with the WAF. And then we block access separately to kind of all the known no places, admin interfaces, private endpoints. So there's like more rules there, but I'm not going to show you our production rules, but like 10. There's some limits in the WAF, at least used to be, that you hit magic number in amount of rules in your ACL and then you're like out of ideas. I think they increased the limits based on our and few other customers' requests, so enjoy. I was hitting that 10 rules per web ACL and 10 conditions per rule quite easily. But it's not a very complex setup. And then we have some header value checking as well. So if host header is xxx.rovio.com, then allow it in. Yeah, that's basically it. The WAF setup is pretty simple, so it's not hard to get it right.
All right. I think we need to move forward.
Okay. Thank you.
All right, thank you, Mika. And next up, we will have Vesa from Rovio as well, talking about their machine learning setup.
Joo, selvä. Mä voin kanssa yrittää vähän pitää vauhtia.
Mites niin tää käynnistetään? Tämä. Right. So hello, I'm Vesa from Rovio, and I'm going to talk about how Rovio uses machine learning to acquire, retain, and monetize users. Fancy title, I didn't come up with that by myself. Anyways, yeah, and I'm senior data engineer. I guess Mika already told you highlights. Next year will be the 10th anniversary of Angry Birds, so we'll have a movie out and something nice.
Oh, okay, keep the mic closer. I'll try.
And today's agenda, I'll start by telling what's live operations in mobile games, since a lot of the machine learning is somewhat tied to that topic. Then a little bit about how we handle data at Rovio, kind of very nutshell presentation similar to what Heikki talked about in length a while ago. Interesting to see that we have same problems but a little bit different solutions. And then the actual machine learning part. And finally, like how can we act on the results of the machine learning? So if we predict something, how can we act on that prediction? So live operations. Basically, nowadays when a mobile company launches a game, they do a soft launch, they pick up couple of countries, launch the game, watch closely how much the players are playing, how many stay in the game for a week, and numbers like that, and tweak a little bit of that and a little bit of this, and try to get the numbers good enough that the game can actually survive in a real market. After that, modern game needs events to survive, to keep the players engaged for longer periods, and then of course player support to address any issues, and also like tell the game team what's bothering the players about the game. And one major thing is user acquisition, so you need to advertise your game to get players in, and the cost of your advertisement must be less than what you get from those players, so that's an interesting problem. And that happens over the whole game life cycle. I watch a game life cycle for some of our games, it's like they keep growing every month, so there's no end in sight. For some others, the story is not quite as happy. And then I also got a comment that sometimes it's maybe not fair to bunch all of this under live operations. Some of the games have been kind of rebuilt over the years, so they don't resemble much what they came out with originally. Okay, about data in Rovio. So what we strive for is single truth. If we ask our game server how many new players we had yesterday, we hope to get the same answer as from our analytics pipeline or from our ads. We never do, but we are working hard to get those numbers as close to each other as possible. Trickier than it sounds. And then sharing is caring, so if your neighboring game team has launched an interesting event and you want to know what happens, you have exactly the same tools as for your own game, and you can also ask, like, do you have nice dashboards for your game? Can I see what was happening? Well, you don't have to ask, can I, but you need to know where to find it. But basically, we try to have all the data available to everyone as far as it's legally possible. And thirdly, we want to own our future, so we don't want to be in a situation that we have our data in a third-party system, and then somebody comes and buys it, and all of a sudden we have 3 months' time to redo our analytics from scratch. But in this presentation, I'm showing how we built all this on top of AWS systems, so you can judge how well we are doing in that front. And one more background slide about Beacon, which is the game service platform we offer to game teams. So it includes client SDK, which makes it easy to connect to all the game services like payment services, ad services, session services. We have charts and reports and customization of the game experience, all kind of pre-packaged, so it's easy to do. We can run A/B tests easily on this platform. And I'm mentioning it because I'm using that beacon notifier on the slides, which are part of the service, most of the slides that is. So here is how the data flow goes, the analytics data. So the mobile client talks to the event gateway directly or to our services, which then talk to the event gateway. Sounds familiar, right? And then the data is pushed into Kafka, not Kinesis. And then we have our data police part. So we actually want to know what kind of data we are storing in the data lake. So we import schemas and we convert it to OR for efficient access. And my story is that it makes the analyst's life much easier when he knows what we have and where he can find it. And also if stuff like GDPR comes up, it's really nice to know where you have your things. You don't have to go through them file by file. And my boss had a presentation about this, how we construct this lake of wisdom in the last re:Invent conference, so you might want to check it out if that's something you're interested in. Okay, so now we have all the events in schemas in data lake. What can we do next? We can calculate the KPIs. We do it on Redshift. Also player profiles, I'll talk about them a little bit soon, are calculated in Redshift. Then the more advanced analytics and machine learning, that's basically Presto, Athena, and then Spark, Hive, or Python. Pick your own poison. You can use whatever you want. We kind of encourage people to use Spark nowadays, but all the other things are in production as well. And then we have this streaming part. Sounds familiar again. Pretty much the same boxes as Heikki had there. We are using Apache Flink to process almost all of our streaming data. Okay, so what are player profiles? That's the information we use for basically all of the machine learning models we are presenting here. And it's just very simple demographics, aggregates, events. So how much time the player spent last month, what kind of devices he using, and stuff like that. Calculated in Redshift, and